I promised you fire and ice. That was the fire. This is the ice. This is something every time you take a breath, you're taking it in. The atmosphere is made of 78% of this as a gas. It's nitrogen. Nitrogen loves to be together. It also, all plants need nitrogen. But around 1905, two scientists found a way to squeeze it down, compress it, and make it cold from a gas to a liquid. And then they invented a new type of science called cryogenics. And so this material right here is so cold, it is minus 321 degrees below zero. And outer space is even colder than that. So let me put some here so you can see what it looks like. You see it's boiling because that glass is so hot compared to it that it's actually boiling. Now it is colorless and you can't see it. What you're seeing is not nitrogen. You're seeing the moist air in this room. When I blow into it, that is all of my breath that has water in it turning into a cloud. If I pick some up, it boils for a second. It makes the glass really cold. But it will boil as soon as I do this. Pretty cool. So you can do that. I would never, you should, I don't think anybody in the world, except for one person, was stupid enough to drink this, because it will kill you. Two ways. One, it will burn anything that touches it. It'll freeze it so bad that it's burnt. I know this because last October 1, I was doing this and I poured some on my tennis shoes. That's all no big problem. What I didn't know is my tennis shoes trapped that liquid nitrogen, and I had 4 holes in the top of my toes that almost burned to the bone. So I'm not going to pour it on my toes. The other way it could hurt you is that it expands 700 times. So if you have 1 cup of liquid, we'll turn into 700 cups. But I can pour it on my hand, I'll tell you why. Because of a thing called the Leisendorf effect. Have you ever watched water on a hot skillet? Your mom goes to cook and put water on there, and it goes, it dances around? That's because the skillet's so hot that it's actually making a steam. The water's not touching the pan, it's dancing on top of it. It's called the Leisendorf effect. And that's what happened when I put it on my hand. Now, I wouldn't hold it in a cup, because then it would burn a hole in your hand. So let's have some fun with it, shall we? So, this is where it gets kind of crazy. Oh, I got this balloon here. It's filled with air. This is like room temperature air. So everybody, the air molecules are moving around like this, like this. If I boil the water, it's going like Plan B. If I boil the water, it's going like this. Okay, come on. Regular air temperature, room temperature, room temperature, room temperature, boiling, and liquid nitrogen, boiling, liquid nitrogen. Let's see what happens. The air in there is just bouncing around. Where's the air going to go? Let's find out. What's happening to the balloon? It's what? It's shrinking. It is. So all that air is starting to shrink. Pour some more on there. And then is the air gone? the air is gone. I think the air is still inside of it. Frozen air. Is the air gone? No, what's going to happen as it warms up, it should come back to its regular size. We can do stuff like this. There's some liquid nitrogen down here. What happened to the air in this boiler? It's still there, I think. It's still there, I think. Oh, not this one. The air slowed down. So, it's so cold that the air actually slows down and stops expanding. That's pretty cool. I've been around of applause for liquid nitrogen. Just take this rose, which is actually 80% water. So when I do this, it is now freezing that rose. And when it freezes the rose, it still looks the same, kind of. You got pictures in there. Push it all the way down. Look deeper again. There we go. Now you're going to do something different. When you pull yours out, crush it over the plastic. Ready? Crush it over the plastic with the other hand. Squeeze it. Very cool. It froze all the juice in the rose. You guys can leave the goggles, keep the rose. Thank you very much. Give them a round of applause. Good question. So, my skin and your skin has water in it. When I say burn, it's actually freezing it so much that it's destroying the tissue, just like a burn. The other reason I said is it's minus 321, but my body's 98. So it is like, it thinks my hand is boiling. I know that's confusing, but it actually freezes anything with liquid in it. So if you put it like on my toe, it froze the skin and all the way down to the blood, and it just made, that stuff was dead. So it looked like a burn. It's actually super frozen. And let me show you, does anybody see a tea kettle? Here we go. Usually, to make a tea kettle whistle, you put boiling water in it. But watch this. I'm going to put liquid nitrogen in it. And remember I told you it expands 700 times its volume? As it expands, it's going out. And if I get it where the tea, where it's, and the bottom is actually getting cold from my breath, and that little bit of nitrogen will keep boiling until two things happen. It escapes or it freezes this pot. These are good though. I like them a little bit colder. Now what would happen when you freeze a Cheeto? Let's find out. When you freeze a Cheeto, it freezes all of the liquid inside of it. And you have dragon breath. You guys are going to have some Sub-Zero ice cream that's going to be this cold. Thank you.